To understand the oil industry, we must first clarify what oil is. Oil is commonly known by two terms, crude oil and petroleum. What is crude oil? Crude oil is an organic liquid found beneath the Earth's surface. It is a compound made up of thousands of different hydrogen and carbon atoms, collectively known as hydrocarbons. Crude oil also contains small amounts of impurities, such as oxygen, sulfur, nitrogen, and some heavy metals. It is highly flammable and serves as an excellent source of energy. Similar hydrocarbons, like natural gas and condensate, are also mineral energy sources like crude oil. Due to their long evolutionary history, these resources are classified as non-renewable energy sources. What is petroleum? The term petroleum derives from the Latin words petra, meaning rock, and oleum, meaning oil. While it typically refers to crude oil, it can also encompass other related hydrocarbons. Some hydrocarbons are gaseous rather than liquid, such as natural gas, which is also considered a type of oil. Petroleum is often stored in underground reservoirs, and these areas of oil deposits are referred to as oil fields. Oil is extracted through drilling and extraction processes. According to mainstream petroleum geology theory, petroleum forms from the accumulation of hydrocarbons. These hydrocarbons originate from organic matter deposited by plants and animals over hundreds of millions of years. Under conditions of high temperature and high pressure underground, these hydrocarbons evolve and aggregate. In simpler terms, dead organisms get trapped underground, where high temperatures and pressures convert them into petroleum. For oil and gas to accumulate underground, three essential conditions must be met. First, there must be a hydrocarbon-rich source rock, which is buried deep enough for the high temperatures underground to cook the source rock, releasing organic hydrocarbons. In petroleum geology, this process is referred to as oil generation. Second, there must be porous rock near the source rock that can store the generated oil. These porous rocks are typically sandstone or porous limestone, known as reservoirs. The pores within these rocks must be interconnected to allow oil and gas to flow out of the reservoir. This property, known as permeability, is critical for reservoir effectiveness. Therefore, studying rock structure is an important step in the search for oil. Finally, a cap rock or seal must exist above the reservoir to trap the oil and gas within, preventing them from escaping to the surface. Petroleum geologists refer to this top layer as the cap rock. Within an oil reservoir, gravity typically creates three layers: gas, oil, and water, which flow from top to bottom. This is why gas and water are produced during oil extraction. Additionally, injecting water and gas can enhance oil production. In some areas where the caprock is incomplete or has been damaged by faults, oil and gas can escape, often leaving behind visible hydrocarbons on the surface, commonly referred to as asphalt or tar deposits. Physical properties of crude oil. The conditions and environment in which crude oil is formed determine its unique physical properties. These varying properties influence downstream refining and processing, leading to different crude oil prices. For example, West Texas Intermediate (WTI) crude oil and Oman crude oil from the Middle East exhibit distinct properties in trading prices. Crude oil properties include specific gravity, measured by the American Petroleum Institute, or API gravity, sulfur content, nitrogen content, residual carbon, and water impurities. Each property has specific implications. For instance, sulfur content affects refinery selection and has environmental impacts. Higher sulfur content is more corrosive and acidic. API gravity is also crucial, as it reflects the boiling points of crude oil components and the number of components that can be separated by distillation. Generally, a higher API gravity indicates a greater concentration of light components. Different oil-producing regions yield crude oils with varying physical properties based on the hydrocarbon mix, resulting in differences in color, composition, and other characteristics. Crude oil is typically classified by type or grade, with the two most common classifications being light crude oil and heavy crude oil. Crude oil is categorized based on its API gravity. A higher API gravity indicates a lower specific density, which corresponds to a lighter color, lower metal and sulfur content, lower viscosity, and easier flow. This type is generally referred to as light crude. Conversely, crude oil that contains high levels of metal and sulfur is considered inferior and classified as low quality, typically containing more carbon and less hydrogen, making it difficult to extract and refine. This is what is known as heavy crude. Another classification is based on sulfur content. Oils with low sulfur content, typically no more than 0.5%, are classified as sweet crude, while those with sulfur content exceeding 0.5% are known as sour crude. Crude oil references. There are 4 benchmark crude oils commonly used in international market transactions. Brent crude oil, a blend of crude oil from several fields in the UK's North Sea. Crude oil produced in Africa, Europe, and the Middle East is often referenced by this benchmark. Dubai Oman crude oil, a sour crude oil produced in the Middle East, primarily sold to the Asia-Pacific region. Tepi light crude oil, a light crude oil produced in Malaysia, serving as a benchmark for East Asian crude oil trading. West Texas Intermediate, WTI, a high-quality, low-sulfur light crude oil produced in North America, primarily used as a benchmark for North American crude oil trading. According to historical records, the world's first oil well was drilled in China around 400 AD. The Chinese used simple drilling tools made from bamboo poles to extract a black, viscous substance from the ground, primarily for fuel. In the centuries that followed, oil was discovered in various parts of Europe and Asia, and some even built reservoirs to store it. Locals utilized this mysterious black liquid for both fuel and medicinal purposes. However, the modern oil industry began in the mid-19th century. On August 27, 1859, Edwin Drake discovered the first underground oil reservoir in Titusville, Pennsylvania, USA. A well drilled just 21 meters deep produced a significant flow of industrial oil. Since the oil was easily accessible and could be refined into paraffin-rich oil for use in kerosene lamps, this discovery sparked oil exploration and production, giving rise to the modern oil industry. As our understanding of petroleum science advanced, more petroleum products were developed. Initially, kerosene was used for lighting. Later, with the advent of automobiles, the industry evolved to include gasoline, diesel, and various other petroleum products, significantly boosting the oil industry's development. By the late 20th century, oil had become essential to modern industry, ranking among its most important sectors. Crude oil has become a crucial energy source in today's world. Everything we eat, wear, and use is closely tied to oil. Without oil, our current way of life would be unimaginable. In essence, we live in an oil-dependent world. 90% of the world's transportation fuels come from petroleum products, and many other significant commodities are derived from petroleum. Over the past century and a half, the advent of petroleum products has greatly enhanced our quality of life and consistently improved living standards. Petroleum is widely utilized in various sectors, from pharmaceuticals to cleaning products. Almost all modern products depend on petroleum in some form. For example, chemical products such as clothing, toys, household electrical appliances, and cosmetics, as well as industrial electrical equipment, agricultural fertilizers, and pesticides, all contain petroleum. Therefore, the importance of petroleum is clear. As the world's population grows and the economy develops, the demand for petroleum energy will increase, as indicated by numerous facts and data. The United States is the world's largest oil consumer. Despite comprising only about 5% of the global population, it consumes 25% of the world's oil production and 45% of its gasoline. If BRICS countries, Brazil, Russia, India, and China, continue to experience economic growth, their need for oil supplies will inevitably rise. Thus, in the long term, global oil demand is expected to continue increasing, although it may be influenced by short-term events such as financial crises or the global spread of the coronavirus, which can temporarily reduce oil demand. In summary, humanity has yet to identify a resource capable of replacing oil. Finding and extracting oil is a challenging and exciting endeavor that requires significant effort and extensive fieldwork, often yielding surprising results. So, how do we locate oil? Exploration decisions are generally based on preliminary survey data. Once oil is discovered, appraisals are conducted. If the results indicate commercial recoverability, production wells are drilled to develop the oil field. Given the importance and unique nature of the oil industry, it is essential to understand it from the perspective of the entire supply chain. First, let's examine the upstream sector, which includes the discovery and extraction of oil from underground. This encompasses exploration activities, such as identifying underground oil and gas reservoirs, drilling exploratory wells to confirm their presence, and field development and production, which involves extracting the oil from the ground. Oil exploration is akin to detective work, involving the search for clues, careful observation of geological conditions, and evaluation of various data. Petroleum geologists, who possess extensive knowledge about rocks, undertake this work. Oil company geologists initially investigate potential oil areas, looking for signs of subsurface oil and gas. They are responsible for selecting optimal locations for drilling wells, starting their research with subsurface formations, and often employing specialized tools like seismic surveys to see through rock layers. Consequently, many advanced technologies, such as aerial photography, satellite imagery, and gravity and magnetic instruments, are utilized in oil exploration. Oil is found not only on land but also in deep oceans. Offshore exploration is typically conducted using specialized vessels, and geologists use a variety of tools, including seismic technology, which employs the principle of sound wave reflection to image seabed formations. However, the only definitive way to confirm the presence of oil is by drilling a well, which carries risks, as not all wells will yield results. Sometimes, several wells may need to be drilled to discover a new oil field, making this a costly endeavor that requires significant manpower and resources. This is why oil company geologists submit their research findings to economists and financial planners for evaluation and decision-making regarding the necessity of exploratory wells. Seismic surveying records seismic waves generated by explosions or vibrations. Different rock formations reflect sound waves differently, allowing seismic surveying to create images of the subsurface. After the initial exploration phase and the completion of exploratory wells, oil field development and production begin once industrial oil flows are discovered. There are generally two types of drilling, onshore and offshore. Underground crude oil is typically mixed with water, sand, salt, and natural gas. When extracting oil, the composition of the produced fluid is adjusted according to varying pressures, and a Christmas tree installed at the wellhead facilitates production. Onshore drilling involves developing oil reservoirs located on land. This process is generally less expensive and carries fewer risks compared to other methods. Once crude oil is extracted from the ground, it is sent to a collection station for processing, where water, sand, and salt are removed. Natural gas is also separated from the crude oil and transported through pipelines. The processed crude oil is then stored in tanks, awaiting transport to refineries or tankers for export. Offshore drilling, on the other hand, is the process of recovering oil from the seabed. This requires the construction of a massive offshore platform, which can be either floating or jack-up. Such platforms ensure that the rig remains stable and can withstand harsh natural conditions, such as high waves, hurricanes, and polar ice. Due to the complex and challenging environment associated with offshore drilling, it typically accounts for 65% of the total investment in oilfield production and construction, carrying significant financial risks. Drilling a dry well, which yields no oil, can lead to substantial financial losses. Discovering underground oil reservoirs and drilling wells are high-risk, complex, and costly operations. The cost of an exploratory well can range from $10 million to $200 million, depending on various factors including the location, onshore or offshore, the size of the oil field, the data being collected, and the types of rocks involved. This is why a thorough understanding of subsurface geology is critical before drilling begins. It requires meticulous exploration and preparation, as well as the development of geological maps to determine rock types and the distribution of potential oil reservoirs, often utilizing advanced geological and seismic technology. Many oil fields are situated in remote areas on land or ultra-deep waters. Oil companies depend on new technologies to overcome these challenges and extract more oil. However, developing such technologies is extremely expensive, often requiring hundreds of millions of dollars in investment. From the discovery of an oil field to the start of production typically takes 5 to 10 years. Oil exploration demands substantial time to raise funds and address various technical challenges. If an offshore oil field is discovered, the timeline from exploration and evaluation to development and production can be even longer, particularly in ultra-deepwater regions. The transportation and delivery of crude oil is a global venture, encompassing both the transport of crude oil to refining facilities and the delivery of refined petroleum products to markets and distribution outlets. Transporting oil from wells to refineries and delivering refined products to service stations necessitates a complex storage and transportation system. Millions of barrels of oil are transported around the world every day via pipelines, tankers, rail, and road transport. Pipelines are typically made of steel and range in inner diameter from 10 to 120 centimeters, approximately 4 to 48 inches, often spanning hundreds or even thousands of kilometers. Advanced technologies are continuously enhancing the size and strength of pipelines. While pipeline transportation is less flexible than other modes, it is the safest and most cost-effective way to transport oil. Almost all major oil fields worldwide are connected by pipelines. Without these pipelines, it would be challenging to transport oil and petroleum products to consumers. For road and rail transport, petroleum products are carried from refinery storage tanks to distribution centers, primarily using specialized rail tankers and trucks. These vehicles are designed with elongated tanks to ensure safety and protect against accidents. Because petroleum and its derivatives, like gasoline, are highly flammable, transportation must be conducted with extreme caution to prevent fires or explosions. Ocean-going tankers, these vessels are specifically designed for the long-distance transportation of crude oil from production sites to refineries, where the oil is typically processed for consumption. Oil tankers are categorized by size, ranging from small coastal tankers to very large crude carriers, ULCCs. ULCCs often transport crude oil from the Gulf region in West Africa to Japan and China in East Asia. Other large tankers transport crude oil from the Middle East or Africa to the northeastern United States or across the Mediterranean to various European countries. Discovering and producing oil is only part of the overall oil process. Crude oil must be refined and processed into consumable finished products before it can be released to the market. What happens after oil is found? Once the oil is extracted, significant quantities must be transported to specific locations for processing before they can be shipped internationally. This segment of the oil industry, known as the downstream sector, involves refining and processing crude oil into various refined products. It also encompasses the transportation and marketing of these refined products. The process of extracting impurities from crude oil is called refining. This process also separates crude oil into various marketable petroleum products, all of which take place in a refinery. All refineries perform three basic functions: separation, conversion, and processing. Today's refineries are highly automated and utilize numerous advanced technologies. As a result, constructing a typical refinery costs billions of dollars, requires millions more to operate, and employs hundreds of people to run continuously, 365 days a year. Separation. This process involves heating crude oil to various temperatures within the refinery. Because the different components of crude oil have distinct boiling points, they are separated as the temperature rises. This separation occurs in distillation columns. The lightest components, such as gasoline and liquefied petroleum gas, LPG, evaporate the fastest and rise to the top of the distillation column, where they cool and condense into liquids. Medium components, like kerosene and diesel, condense in the middle section of the distillation column. The heaviest liquid component, known as residual oil, has the highest boiling point and remains at the bottom of the distillation column. Refineries also utilize chemicals called catalysts to help remove carbon or increase hydrogen content during the refining process. Refining processes are continually improving, with various complex operations designed to enhance output. Today, refineries can convert more than half a barrel of crude oil into gasoline, a significant improvement compared to 70 years ago, when a barrel of crude oil could only yield a quarter of a barrel of gasoline. Conversion. This process involves cracking, or breaking down larger hydrocarbon molecules into smaller, more desirable ones under high temperature, pressure, and chemical catalysts. This commonly used conversion method is known as cracking. Conversion occurs in a cracking unit, which includes thick-walled reaction towers, large furnaces, and isolation compartments. Beyond simple separation, other refining processes involve recombining hydrocarbon molecules to form medium-quality oil products, desulfurizing, and removing impurities to lessen the environmental impact of the refined products. Refineries also process waste products to minimize air and water pollution. Modern refineries are equipped with advanced pollution control systems that purify wastewater, eliminate harmful chemicals, and regulate the emissions of exhaust and toxic gases. A refinery is a complex of interconnected buildings and plants that pretreat and fractionate crude oil. These fractions are then converted and further processed before being blended according to predetermined specifications to produce the desired petroleum products. Processing, this final step involves treating the separated components to enhance their quality. It typically includes blending them with other elements to produce the final product. Crude oil refining produces a variety of products, including gasoline, jet fuel, diesel, and petroleum coke. Once refined, these products are stored in large tanks before being shipped to various locations where they are needed, such as gas stations, airports, and chemical plants. Apart from fuel oil, refineries also generate other oil-based products like asphalt, cleaning solvents, coatings, and even raw materials for household chemicals. The final step in the downstream sector is delivering refined oil products to the market, which is most commonly seen at gas stations. Presently, most vehicles still rely on gasoline or diesel as their primary fuel sources. Oil is extracted from the ground and goes through multiple stages before it reaches consumers, making the oil industry a complex energy supply chain. In summary, the oil industry consists of three major sectors: upstream, midstream, and downstream. The upstream sector involves exploration, oilfield development, and oil production. The midstream sector encompasses transportation, processing, storage, and transshipment, and the downstream sector includes refining, petrochemical production, and marketing. While the upstream sector serves as the core of the oil industry, it also supports numerous oil service-related companies. In essence, the oil industry is a vast and intricate industrial system. Thank you for watching. Please follow and subscribe to my channel for more programs about oil industry.